Okay, so today we're talking about linear programming. We are creating systems of equations to help model real world situations, maximizing profit for companies, or possibly minimizing costs. This is something that is an extension for our class. We won't be testing over this. So today we're just doing our best, try to soak up as much as you can, and then we can go over any questions when I return. So you should have your notes in front of you. It says a furniture company makes bookshelves and desks. Each shelf requires 2 hours of carpentry. So carpentry is like actually putting it together, and 1 hour of painting. Each desk requires 3 hours of carpentry and 4 hours of painting. The company has a maximum of 60 hours of carpentry work and 40 hours of painting available each week. They make a profit of $15 per shelf and $40 per desk. How many shelves and how many desks should they make? So what are we trying to figure out if they can make, or how many shelves and desks? So I'm going to make X my shelves, my bookshelves, and Y will be my desks. So that's going to go into my table below here. So shelves and desks, X, Y. Okay, so what goes into making those? Carpentry work and painting work. So I'm going to have my carpentry on the left, and then below that painting. And then I'm going to reread. It says each shelf requires 2 hours of carpentry. So I'm doing shelves, carpentry. Okay, they line up right here. That's 2 hours. 1 hour of painting. So shelves and painting, one. Each desk requires 3 hours of carpentry and 4 hours for painting. So desks take 7 hours total to make. Shelves then take 3 hours. Okay, so the company has a maximum of 60 hours for carpentry. So this is our total allotted time, 60 hours. They have a maximum of 40 hours for painting. So let's create the constraints now from this information. The carpentry constraint, they can build, it takes 2 hours for however many shelves they build, so 2x, plus 3 hours times however many y desks they build, and how much time they have. All of that has to be less than or equal to 60. The painting constraint is 1x plus 4y less than or equal to 40. Our objective function talks about our goal. So this is typically talking about cost, profit, possibly revenue. It's what are we trying to do? What's the end goal? We're selling these things. We're making them to sell them. So our objective function for this is a profit function. So profit, we'll do P equals. If we were talking about cost, I might do C equals. If we're talking about revenue, I might do R equals. So P equals, what are we selling? We're making a profit $15 per shelf. So 15 shelves are X. Plus $40 per a desk, so 40 Y. Okay, so now if I want to go ahead and graph these, I can take both of these inequalities and I can solve them for Y to try to graph them. That's kind of going to be a pain though. An easier way to be graph using the intercepts. So I'm going to find the x-intercepts and the y-intercepts. So first starting with my carpentry. Remember that cover-up method? If I'm finding the intercepts where they hit the x-axis, it's going to be some number comma 0. So if I plugged 0 in for y, this goes away and I get 2x. We can convert this to an equal sign for now. Divide by 2, so x is 30. So 30, 0. Now I need that back, so I probably won't cross it out anymore. but this should be 3y. Now for my y-intercept, I know it's 0 comma some number. So I'm going to plug in, so it should be 3y equals 60, divided by 3, so y equals 20. So I know it hits the x-axis at 30, y-axis at 20. Okay, then my painting situation. I got, for the x-intercept, cover up the y, so 1x equals 40, so that's 40, 0. Y-intercept, cover up the x, so that's going to be 0 something. So that is 4y equals 40, divided by 4, so it's 10. Okay, now let's graph this. So ultimately, these are inequalities, so we are going to have some shading. I'm concerned with the shaded region that is double shaded. I'm also concerned with the intersection point of these two lines. So my x-axis is talking about shelves, and my y-axis is talking about desks. So let's think, how far do we have to get on our x? We have to get to at least 40, and our y-axis, we have to get to at least 20. So I'm going to go ahead and increase by tens. Another good scale would probably be 5s would be good. I probably wouldn't go to much lower than that though. Try to make them kind of evenly spaced. You could use a ruler if you want. We're just kind of drawing a sketch of this, so it's okay if it's not crazy accurate. Okay, my carpentry line, x-intercept is 30, y-intercept is 20, and then I'm going to connect them. Now I can shade below it because it is less than or equal to. My red line is my painting line. X-intercept is 40, y-intercept 10. Connect those, and I'm going to shade below that line. So notice the double shaded region is made up of this ordered pair 0, 0. These are would be called the corner points. Okay, and all the way to this one, 0, 10. I'm going to go over this way. Oop, that's where they intersect. I don't know what that ordered pair is. I can't see clearly. So we will find this one algebraically. Okay, and then we come down to here. This ordered pair is 30, 0, and then it goes back over. So this is our double shaded area. So all of these corner points are possible values that fit our constraints and could help us maximize our profit. So in order to kind of eliminate and figure out which one is going to maximize our profit, the next thing I'm going to do is identify this ordered pair where the two lines intersect. And because when I'm finding this ordered pair, I don't care that they're inequalities. I want to know where the equations intersect. I'm going to go ahead and flip my paper over, and I'm going to use these inequalities, but I'm going to convert them to equations. So go ahead and flip your paper over. Right, so I have my two equations here, converting them to equations. Now I want to solve for their solution. These are set up to do elimination. That's the method I would use. You could easily do substitution though. So if I'm doing elimination, I need something to cancel out, and I do elimination using addition. So I'm going to multiply the second equation by -2. So I'll just rewrite my first. My second equation, distribute -2 to all terms. Next, add the two equations. 2 plus -2 is 0. 5 plus -8 is negative, or sorry, 3 plus -8 is -5. Those are y's. 60 plus -80 is -20. Divide by -5 on both sides. y equals 4. Y is standing for des, so that's 4 des. I need to find out how many shelves though, so I'm going to take that, plug it back in. So this is 2x plus 3, y is 4, equals 60. 2x plus 12 equals 60. Subtract 12. X is 24, and that's bookshelves. Okay, so let's take a look. I'm going to go back to the front side of my paper, flip yours over. I just identified that this order pair right there is 24, comma 4. So I'm going to write that in. That is one of my possible corner points on my sheet. Okay, so the last part here is we want to check what's going to maximize our profit. So I've provided you with a little table. On this table, I have listed the points. Notice I didn't list the point 0, 0, because that would be selling 0 shelves and 0 desks, which would give me a profit of $0. So I just kind of threw that corner point away right off the bat. My corner points are listed 30, 0, 0, 10, 24, 4. My objective function is my goal. I'm trying to sell these items. So that's P equals 15x plus 40y. If I would like to find out what the profit is, I'm going to plug the x and the y into the equation. So that's 15 times 30 plus 40 times 0. So that's 450. 15 times 0 plus 40 times 10, that's 400. 15 times 24 plus 40 times 4, that gives me a profit of 520. Now, if I wanted the maximum profit, I want the highest one here. So this is the highest possible outcome. Within the constraints of, I can only spend 30 hours of carpentry, and I can only, at most, spend 40 hours painting. So I've maximized out my time with those two things that I have. I've maximized out how much each of those take, and I have figured out that it will be best for me to spend my time building 24 shelves and 4 desks. That gives me a max profit of $520. Okay, so the last thing for today is taking a look at your homework. So if you need to pause the video and get your homework, grab that now. What I would like you to do is go through all of these. There's 4 questions. You are not today going to be graphing. You are not today going to be identifying like your final answer or anything like that. Today, all I'd like you to do is attempt to set up this table, okay? Attempt to find your constraints, your objective function, and if you feel prepared, then you can try to, well, let's just stop there. And if we can we'll just check our equations and everything in the next class and then move on. And be able to graph after we check everything to make sure it's all set. Okay, so just a reminder on number 1, read it very carefully. There is only one equation. However, there are 3 additional constraints. So that would come from at least 30, but no more than 60 type X, no more than 70 type Y. So there's going to be inequalities like X greater than or equal to a number, X less than or equal to a number, Y less than or equal to a number. Okay. Let's see here. And ultimately, we are minimizing the cost here. Take a look at number 2. We're talking about audits and tax returns. I have helped you set up the objective function. It's talking about what we're charging people for, and I have set up the start of the table for you. The rest is for you to tackle.